Okay, let's talk about changes in state. Take your notes sheet, and as I go through, please fill in the information as I explain it. Um, Basically, a lot of this is going to be a review for you. It's some of the things that you've been reading about and writing about. The first is evaporation. And the reason why we have to talk about evaporation is because there is a difference between vaporization and evaporation. Vaporization is the conversion of a liquid to a gas or vapor, whereas evaporation occurs on the surface of a liquid that is not boiling. So, off of the surface of a liquid. Now, what you have to remember is that as a liquid becomes a vapor, it is gaining kinetic energy. And so only those molecules that are able to collect enough kinetic energy can escape from the surface of a liquid. So they're moving, 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 moving. And then at the point when they reach a level of kinetic energy that allows them to move into the vapor stage, phase, excuse me, then they leave off of the surface. As a liquid is heated, evaporation rate will increase. And that is because, of course, heat increases the average kinetic energy, which allows those particles then to overcome the forces that are keeping them in the liquid state. Now, let's look at this comparison of vapor to liquid. Okay, so we have a liquid here and a vapor here. If we're going from vapor or gas to liquid, that is condensation. If um, that involves a loss in heat. If we are going from a liquid to a vapor or gas, that is evaporation, vaporization, and this is what it looks like somewhat. If you look, this is the surface of the liquid, or representing the surface of the liquid. And what you'll notice is that at the surface, just every now and then, a molecule will escape the surface, and that is moving into the vapor phase. And so there is a gain in heat necessary in order for that to occur. Now, vapor pressure. This is probably a new term. I don't know that we've necessarily talked about it in any other science class. Maybe in middle school you did. But it is the measure of the force that is exerted by a gas above a liquid. So you have a liquid, and then there is force coming down upon that liquid. A constant vapor pressure is when there is a dynamic equilibrium that exists between the vapor above the liquid and the liquid itself. And what that means is that the rate of evaporation is equal to the rate of condensation. Now, here are two models for you to look at. If we were to look at this bottle right here, where it has an open cap, and so the molecules can escape from the liquid form to the vapor form and exit the neck of the bottle. Example of an open container would be a pond in a forest. Here is a closed container. This is called a terrarium. It's kind of like a mini greenhouse. And notice that there is a lid on it. And right here is a rubber stopper. And what you'll see is that water is not, or liquid, I'm saying water because I'm assuming it's water. Um, Water is not escaping from the surface from the bottle at all because it's enclosed. And so what happens is at some point there is an equilibrium reached in which the number of molecules that are moving into the vapor stage equal the number that are moving into the liquid stage. So condensation and evaporation are occurring at the same rate. Over here, I forgot to mention that, yeah, there is some condensation occurring, and you can see that right here, but it is not nearly at the rate of the evaporation. So, boiling. Now, you boil water for your mac and cheese or your spaghetti, but have you really thought about what's happening? Yes, liquid in an open container is heated. The temperature increases, and particles throughout the liquid have enough kinetic energy to vaporize. But what happens is the liquid begins to boil, and bubbles of vapor form in the liquid, and they rise to the surface and escape into the air. So we term or explain the boiling point as